Well, welcome everyone to our 615 broadband seminars. As you know, these seminars take place every month. You can already mark on your agenda the date of our next seminar, which will be the 25th of January, presented by Janice Bosch. And if you want to join us for the next seminars, you can just sign up, scanning the QR code that you can see on the slide. It's our webpage, so you can also go to the SIG15 webpage directly and sign up for it. You will receive the links for the upcoming seminars once they are organized. So today I'm very happy to introduce Inmaculada Fajardo. Ima is an associate professor and member of the Reading Research Unit of the University of Valencia in Spain. Her focuses on the study of reading and language difficulties in population with neurodevelopmental disorders, intellectual disability, autism, and hearing disability. And among other techniques, she has specialized in the registration and analysis of eye movements. So, Ima, thanks for accepting our invitation, and be welcome to start sharing your screen when you want.
Okay, thank you. So I'm sharing it. So thank you for the introduction, Nadina. I'm very glad to be here presenting this work because I think that one of the areas in which the results of our study may have a higher impact is in the area of education, and in particular in the area of special education. Today I'm going to present the preliminary result of this study, which focused on the impact of the type of face mask on speech perception for people with and without hearing loss. I wanted to say before starting, because it's not in the title, that today I will present just the result of the control group, that is the result of the participants, adult participants without hearing loss, because this is an ongoing research and we are still collecting data, recruiting participants, and maybe, as you know, it's very difficult to collect people of some population. But I hope that in the near future we have more data to present of the whole study. Before starting, I wanted to thank to my co-authors, Nadina Gomez, Antonio Ferrer, and Isabel Rodriguez from the University of Valencia and from the University of Sevilla for their involvement in this study, because otherwise it wouldn't be possible to do it. So I will start now explaining why we are interested in this phenomena. Maybe all of you have had problems during the COVID-19 pandemic communicating with other people due to the use of face masks. Imagine that you can imagine then that the problem of the communication difficulties that may have affected to adults and children with hearing loss have been very, very much significant for people with hearing loss that with people with typical hearing, because this population depends more on visual cues to interpret and to perceive and to comprehend speech than people with typical hearing. Actually, in Spain and in other countries, there has been campaigns for promoting the use of transparent face masks, which would benefit especially communication for people with hearing disabilities or hearing loss. For example, in Spain, Fundación Universia has distributed for free transparent face masks, the one that you see here in this picture, the first pictures, and which is the one, by the way, that we have used in our study to compare with other models. As I said, Fundación Universidad distributed this type of face mask between teachers of students with hearing loss at the universities, in several Spanish universities. And the same happens at the level of the primary and elementary school. But in the case of elementary and primary school, they distributed a different type of transparent mask. Actually, the model is this second semi-transparent masks. And in other countries, for example, in Gloucestershire, or countries or regions, there are also campaigns to promote the use of transparent or semi-transparent face masks or other devices which may help people with hearing disability to communicate, but still being secure, because it's mandatory to use these devices to prevent the COVID-19 pandemic. Okay. So this phenomenon, which is now very relevant for everyone, has been studied for decades in science, in medicine, in psychology. Researchers have been very worried about, or have been curious about, this phenomenon. Actually, thanks to previous research, we know that the optimal perception of spoken language involves the integration of auditory and visual information, especially in noisy situations. We know that thanks to three main experimental paradigms: the McCurk paradigm, or the McCurk task, which it was designed to induce an auditory illusion. I'm not going to explain the McCurk effect because it would take too much time. But if you are curious, you can find many papers about this phenomenon, which prove that our mind mix or combine information from the visual system and from the auditory system when we are trying to comprehend speech. The second and third paradigms, and the speech recognition in auditory noise and the speech recognition in visual noise. The logic of these two paradigms is to decrease the quality of the auditory or visual signal and measure how much speech perception is possible when you remove or reduce this type of cue. Okay, so for example, using the paradigm of speech recognition in visual noise or blurring, Ty and Murray found that when the whole facial image of the speaker is blurred, as you can see in the right hand side image, the speech recognition ability of a young listener, or a young person with typical hearing, drops from 80% of accuracy to 60%. And if in addition the acoustic signal, the auditory information is not available, this recognition accuracy may drop up to 20%. Which is, these percentages are similar to the percentages that we have found in the study I'm presenting today. But in this previous study of Ty and Murray, and in many of the studies that you find in this paradigm, the blurring of the visual noise usually affects to the whole face. But what happens when the visual noise affects only to a particular region of the face, like in the case of face masks? This is a question we ask in this the study I'm going to present. How much and in which way does the use of different type of face masks affect people with or affect speech recognition, sorry, in people with and without hearing loss. There are some previous studies already published about the effect of face mask on speech perception accuracy. So we know, if you see the revision of Thibaudot, you can see some experiments which find that the speech recognition accuracy decrease with the increasing mask opacity. The higher is the opacity of the interference of the face mask, the worse is the speech recognition accuracy. For example, Banduru, I'm going to mention just two previous studies, Banduru and Cole, which is in paradigms of speech perception found that people with typical hearing, in people with typical hearing, the perception threshold for words, that is the perception threshold is the amount of sound intensity that you need to perceive the presentation of a word or of a sound. In this case, they use words without noise, increase an average of 12 decibels. That is, you need more intensity, more sound intensity to perceive words in noise when the speaker is wearing an opaque face mask with plus a transparent screen. In this experiment, they just used this condition, opaque face mask with a transparent screen in addition, which is the combination of devices that physicians use in the health system for more security. In another experiment, Thibaudot and Coles found that the speech perception in noise decreased with transparent and opaque masks in both hearing and deaf people. As you see, the higher the opacity of the face mask, the lower the perception or the percentage of correct answers in the speech recognition task, especially for those people with hearing loss who uses prostheses, which means that people with a higher degree of hearing loss are more affected for the opacity of the face mask. But what about face exploration? So on base of previous research, we know that the speech perception accuracy is affected by the use of face mask. But what about how people explore the speaker face? Is there any difference? This is the second question that we wanted to answer with our research. Based on previous research, without face mask, we know that people with typical hearing tends to spend more time looking at the eyes of the speaker than to the mouth of the speaker. This is called the eye primacy effect. Why? Probably because when the auditory signal is good, you have enough with the auditory information, so the fixations on the eye regions provide you with more pragmatic information, like turn taking, the emotion of the speaker, the intention of the speaker. This makes sense. Other researchers have also found what they call the social tuning, which is the tendency to look at the mouth during the speech and to the eyes during the silence in this conversation. So there is a trade-off between eyes and mouth in order to have auditory information or visual information which can be useful to discriminate syllables, and eyes information or information from the eyes which may serve to interpret the emotion of the speaker, the intention of the speaker, or the turn taken in a conversation. But we also know that the speech perception, or the exploration of the face of the speaker interact with the conditions, auditory and visual conditions of the environment. So listening in auditory noisy situations increase mood fixations by typical hearing adults, while visual noisy situations, for example, blurring the face image, decrease the mouth fixations. So this is what we knew from typical research with people with typical hearing in regular situations without face masks. What about people with hearing loss? We know that children, there is not much research, but I'm going to describe just very briefly the research, one study with children and one study with adults, deaf participants. In the case of children with prelingual deafness, Worsters and Coles found the pattern of social tanning, that is, they look at the mouth during speech and to the eyes during silence, and this pattern correlates with their ability to lip read. That is, the higher was the social tanning pattern, the better the better was the ability of children with deafness to lip read. So somehow this study demonstrates that there's a relationship between the way we explore the face of the speaker and the speech comprehension or the speech recognition or perception. On the other hand, Rodriguez, Saldaña, Mastrantorno, I said all the names because they are colleagues from the University of Sevilla, found that deaf adults look more than hearing adults at the speaker mouth area than at the eyes area in spoken speech. That is, if you compare hearing people and deaf people, patterns of eye movement over the face of the speaker, people with deafness look or spend more time looking at the mouth area than to the eyes areas than people with typical hearing. This is interesting because maybe it means that they need more information from the mouth, no? Which is common sense, but somehow this is a demonstration, empirical demonstration of this fact. So the goal of our study was to explore how adults with and without hearing loss perceive speech with different face mask types and hearing conditions, which was something that was not done before. And in particular, we wanted to check whether the use of face masks affected comprehension of words and sentences, and our general prediction was that the more visual interference, the worse would be the comprehension in both participants with hearing loss and participants with typical hearing, but especially in the former group. And regarding the pattern of eye movement over the speaker face, we predicted or we expected that the more the visual interference, that is, there are more visual interference with an opaque face mask than with a transparent face mask, and there is more visual interference with a transparent face mask than with no mask. of wearing no mask. So we expected a progression in visual interference between no mask and opaque face mask. The more time in the eye region and lower fixation time in the mouth region. So the more visual interference, the higher time participants we will spend on the eye region and less in the mouth regions. And we expected too that participants with hearing loss will make more fixations on the mouth region in general, based on previous research. So they would be more dependent on the mouth region. But as I said before, we are going to present just the results of the group of participants with typical hearing. So we just can check today the red part of the predictions. So what about the design? Well, in our study, we recruited 2 groups of participants. Adults with typical hearing. So far, we count on 35 participants aged 19 to 50 with college education. All of them, I think, were undergrads. And so far, we only have 7 participants with hearing loss, with moderate to profound bilateral hearing loss, and secondary education or higher. We expect to complete the sample of adults with hearing loss from now to February. So fingers crossed that we have everything, because when we have access to participants, to the population, we don't have the eye tracker available and the other way around. So it's been quite difficult to complete the sample for this study. Well, in any case, we asked participants to complete a task of speech perception in different conditions, and several complementary tasks of receptive language, working memory, and nonverbal intelligence. We asked them, regarding the speech perception task, we asked them to repeat words and sentences that they heard in different audio and video conditions, and with the speaker wearing different type of face masks. In each condition, they had to hear and see a video of a model saying 25 words per condition that we obtained from a standardized instrument, a Spanish one. In each condition, the list of 25 words were balanced according to the familiarity of the word, the phonetic, the syllabic complexity, and the visible point of articulation. This is very important. So in every list per each condition, the features of the 25 words were similar. And in addition, once participants listened and repeat the 25 words, they were presented 4 sentences per condition obtained from a standardized test too, and they have to repeat the sentences or what they could understand. We followed a mixed quasi-experimental design with 2 groups, participants with and without hearing loss, 3 levels of audio availability, audio and video, only audio or only video, and 3 levels of face masks, no mask, transparent mask, and opaque mask. The design was incomplete, and as a consequence, we only have 6 experimental conditions because some conditions were impossible. For example, we couldn't present the opaque condition without audio because it was impossible to repeat anything because there were no audio and no video signals. So this condition was removed. As a consequence, we had only 6 experimental conditions. No mask with audio and video or only video, transparent face mask with audio video or only video, opaque mask with only audio and video, and then we have the no mask condition. No video condition, only audio conditions, in which we use the audio of the no mask condition. So 6 experimental conditions, and we counterbalance the list by the condition by different presentations order in order to prevent an effect of presenting always first, for example, the visual or the audio video no mask condition. This or the order of presentation was varied between participants in order to prevent this learning effect or this order effect in general. As a measures of the speech perception task, we had the percentage of correct repetitions of word or sentences, and as measures of eye movement, we collected the dwell time percentage in 6 areas of interest: hair, the front of forehead, the eyes area, the nose area, lips, and neck. Dwell time percentage is the percentage of time spent in each area of interest, and it's a combination. The dwell time is a combination of fixation times and saccade time. In dwell time, everything is used, saccades and fixations. Just in case you are curious, but this is a detail that maybe you don't care about if you are not on this area of eye movement research. Regarding analysis protocol, we conducted several generalized linear mix models per stimulus types. So we conducted an studies per words and a different analysis per sentences and areas of interest. And also we conducted several analyses to explore the effect of mask types and audio type, because as I said before, the design was incomplete, so we couldn't merge everything in the same analysis. So first, I'm going to present the preliminary results of the control group, and I will start with accuracy. As you see here in these 2 graphics, we are representing the effect of audio availability on the percentage of repeated words. On the left-hand side, you have the effect on the words recognition, and on the right-hand side, you have the effect on sentence recognitions. You see that you can clearly see, I think, that the only video condition obtained significantly lower performance or accuracy than the other 2 conditions when the audio was available. Okay, so the only video condition obtained around a 70% of accuracy less than in the other 2 conditions. When the audio was available, either with video or not, the accuracy was quite high, actually nearly perfect in all cases with words and with sentences, but when audio was not available, the pure visual speech perception, let's say, was around 30–70% of accuracy. What about the effect of type of mask? Let's see the result regarding words. As you can see, the effect of type of mask was almost was significant, but the performance, the accuracy was very high in general when audio and video were available. Also, as expected, in the condition of no mask, the accuracy was higher than in the case of opaque mask. However, in the case of the only video condition when no audio was available, so only the visual signal, the speed recognition depends significantly or varies significantly depending on or as a function on the type of face mask. In particular, when the speaker was not using mask, in the condition of no mask, the accuracy was higher than in the case of transparent mask. Okay, and same, well, similar patterns happen in the case of sentences. The accuracy again was higher when audio and video were available, but the effect was up in the case of audio and video availability. In the case of sentences, the effect was opposite to the expected. A participant obtained a higher accuracy with opaque face mask that in the case of no mask. The difference in terms of percentage is very, very low. It's like 98% with no mask and 100% in the case of accuracy in the case of opaque mask, but still is significant. And as you see here, I said, I asked to myself, is that an artifact of the procedure? We can discuss it later, but as I said at the beginning, I think it's an artifact of our procedure, which was an advantage for the opaque mask because the sentences always appeared at the end of the session, of the trial, let's say. So participants saw 25 words, and after 25 words, they were presented 4 sentences. So in the case of opaque mask, when they have seen 25 words with the opaque mask, somehow I think that participants learned that the visual information was not useful at all, so they concentrated more in the audio information. This is the reason I think we have this effect, but taking into account the procedure, I think it's an artifact of the task. And in the case of only video condition, the difference between opaque, no mask and transparent mask was not significant. What about eye movement, which is maybe the more original part of the result? We firstly have a look to the distribution of dwell time per areas of interest, and as you can see, the most of the dwell time was spent in the eyes, nose, and mouth regions. So from now in advance, we decided to concentrate or focus just in these 3 areas because the other areas, hair, front, and neck, are not that informative. So what you have here is the effect of type of mask when the audio and video are available. let's see it for each area of interest. As you see in the case of the eye region, we see that the effect of typos mask was significant, and as expected, the opaque face mask and the no mask condition were the conditions with higher dwell time percentage. But we had expected that in the case of the transparent mask condition, the time spent on the eyes was higher than in the case of no mask, because there is more visual interference in the case of transparent mask. But however, it was not the case. If we analyze now the area of the nose region, we see the expected pattern. That is the higher the visual interference in the nose region, which is higher with the opaque than with the transparent and with the no mask. In the no mask conditions, the lower is the dwell time spent in this area. And again, in the case of the mouth region, we have a strange pattern, because in effect we find that that with the opaque face mask, the number of the dwell time invested in the mouth region is very low, because it makes no sense to use this area. Is absolutely blocked by the face mask, so participants omit or ignore this area. They invested more time, however, in the no mask condition and in the transparent condition, and but the difference between no mask and transparent was not significant, and we had expected that it was. What about the effect of this mask when no audio was available? We see that as expected, and it was a prediction that we had, the number of fixations in the mouth was higher than in the case of audio and video availability, especially in the case of transparent mouth, which is what was not expected. We expected higher fixations in the mouth in the no mask condition, because there was no visual interference at all. What about the effect of audio availability? It's more or less the same result, but seen from another point of view. We found that the effect of audio availability was significant for all types of masks and AOEs and areas of interest, but with different patterns. As predicted, dwell time increased in the mouth area when audio was not available. So this results, from this point of view, this result confirmed our hypothesis, that is the lower the auditory signal, the higher the fixation on the mouth area, and the lower the fixations in the eyes and nose regions. Conclusions. I know that I presented too much information in a very short time. It's difficult to follow because the design is a little bit complex, but well, I'll try to make a resume here. Regarding accuracy, we can say that when audio is available, words and sentences recognition is very high, about 90% with all type of masks for participants with typical hearing. This is important. We have only presented the result of adults with typical hearing. But when audio is not available and we just have to use visual information, words and sentence recognition decrease to about a 20%, 25% of accuracy, especially with the transparent mask. And which is, somehow this result is similar with what we saw that happened in previous research. And what about the profile of the pattern of speakers' face exploration? In typical hearing adults, again, we find the eye primacy effect with confirmed this previous research of Smith. But this eye primacy effect occurs in the no mask and audio condition, and the pattern is similar when wearing opaque mask. And sorry, I'll explain it again. This pattern of eye primacy effect is even stronger when participants are wearing opaque mask, which is quite sensible because there is not information at all in this area, and it is consistent with previous research. However, when no audio is available, the dwell time percentage for the mouth increases, and that for the eyes decreases. So when the quality of the audio information disappear, well, the quality, no, the audio information disappear, the information provided by the mouth is more important. So participants increased their percentage of time fixating this area and decreased the percentage of time fixating the eyes. A pattern much more evident when participants are wearing transparent masks, which is not that consistent with previous research, because we expected that this pattern was ameliorated with transparent mask. We compared it with no mask condition, in which we expected higher percentage of dwell time, because it was the condition in which the mouth was more available. In other words, we're wearing a transparent face mask, especially if no auditory information is available, the pattern of eye inspections is opposite to the usual one. Future, we have to collect the sample of adults with hearing loss and explore and test the hypothesis. We expected that in the audio and video and audio only conditions, they will have more difficulties than adults with typical hearing, especially with the opaque masks. And in the video only condition, we wonder if they are better lip readers because their experience in lip reading, maybe they should have an advantage in speed perception in this condition in comparison with people with hearing loss. And what about the pattern of eye movement over the speaker face? We will expect theoretically more that the more the visual interference, the more eye fixations, but we have found this pattern was not that clear for people with typical hearing. So we will see what happened, and we expect that participants with hearing loss will make more fixations on the mouth in general, and we don't know which would be the effect, this effect of this pattern when we add face masks. We would like to explore the tuning, the social tuning pattern too, but we haven't done yet. But we could do it with our data, but we haven't done yet because the analysis is very tedious. And also we could analyze our data depending on the type of words, because we have stimulus enough to make classification of words as a function of the point of articulation. And we could compare words in which the visual point, the visible point of articulation, the point of articulation is visible or not, and compared is the face mask, and the exploration of the face of the speaker varies as a function of the visema or point of articulation. Applied conclusions. Well, so far, of course, we have conducted just this research with adults and with adults with typical hearings, but we would like to collect, we expect to have more data and to be more conclusive about the applied conclusions for people with hearing loss. And if possible, we would like to replicate this study with children, would be very interesting too. But so far we could say that transparent and opaque face masks allows speech recognition when auditory signal is present, but otherwise speech recognition is affected. And also speaker facial face exploration, it seems from my point of view to be more costly when the transparent face mask is the speaker is wearing transparent face mask. From the data, I infer that exploration is more costly because the participants have to invest more time is inspecting this area to have the same amount of accuracy than in the case of, or even worse, amount of less amount of accuracy than in the case of no mask condition. I think that it's important to know that when only visual cues are available, transparent masks allow just a 20% of speech recognition. So I wonder if this accuracy rate is enough to advise for the use of transparent face mask. I'm not sure if this 20% of accuracy compensates the use of this type of face mask for teachers. For example, knowing that the transparent face masks are not as comfortable than opaque face mask, and you have to clean it all the time to prevent fog and to prevent negative consequences. So more than an applied conclusion is a reflection. And another consequence of this result would be that maybe it's a good idea to support speech with other visual cues. For example, if you use video conferencing, you could use captions. Actually, I should have been using captions today. I'm sorry. I should have been using captions today, but yeah, I couldn't prepare it. But nowadays we can do it. It's easy, and it would improve speech perception, not only for students or people with typical hearing, but with hearing loss, but for people with typical hearings. And finally, regarding sign language, I think that it's a good idea for people with hearing loss to support speech or spoken language with sign language interpretation. But note that sign language also uses facial or face gestures. So maybe the use of face mask is also affecting this the accuracy in this type of communicative behavior with sign language. So, well, I think that yeah, it's enough. Thank you. Questions and comments are welcome.
Thank you very much, Ima. Do we have any questions there?
I just have a comment on Ima's final consideration. That was really interesting. Thank you for your presentation. I was thinking about your consideration around that 20%. Is it enough? Also was thinking about the fact that because it was an experiment, the person was also facing the person who was listening. This doesn't happen all the time in the classroom. We know that.
Yeah.
So probably this is going to be a bit less than 20%. It is going to be affected.
Yeah.
So it is on the same line of what you were thinking.
Yeah.
It makes sense to use a face mask transparent that is more difficult to work with. If this is the improvement, but this is great. Thank you very much for your for sharing your.
Thank you. Yeah, this is a good observation. It's true that in our experiment, the participants were just facing the perfect view of the speaker and the sound quality when this was available was perfect, but in a real classroom, it's not. This is not the real situation. In a classroom, the speaker is moving around, is blocking the mouth area. So, based on my own experience with teachers and teaching with transparent face mask, I know that it's very uncomfortable to use this type of face masks. They are more expensive too. So yeah, I wonder if I mean, based on this result, I'm not sure if it is a good advice to recommend the use of transparent face masks. Maybe just because it gives confidence to the people with hearing loss, or maybe if unless you can ensure that the communication is of a good quality.
Yes, but also after you've collected and analyzed the data for your experimental group, you will find maybe a different number there, not just 20. So, but it is everything is very interesting to see.
Yeah. Thank you.
I'm looking forward to. I'm looking forward to hearing about an update on your data collection later in February.
Yeah, I hope so. I hope so. Yeah, we we hope to start with a new period of data collection now in December, and if not, we will stop it and we will start in February. So during the month of February, we hope to collect up to 20-25 participants with hearing loss. Would be, I mean, the collective of people with hearing loss is very interested on this the result of this study, as far as we know and as far as we have talk it with people, yeah, of different services and organizations of people with hearing loss. But it's difficult that people come here to participate. Also because the task is very frustrating for them. I mean, I understand that you don't want to be in a situation where you know that you are not going to do it well. And the participants that we have had so far, they were very worried about that. Yeah, about the fact that they probably were not performing as well as they wanted, and they thought that it was an exam for them. It wasn't, but yeah.
A lot of anxiety.
Yeah, a lot of anxiety, actually. Yeah.
Yeah.
Hmm.
I can't see any question on the on the chat. If anyone has a question, please jump in. It is 2:00 now, so I think it is time to leave. I don't know.
Yeah.
Yeah,
3 o'clock.
Oh, sorry.
Or 3 o'clock
in
in Spain.
You're right. It's 2 in London.
Yeah.
Nadina, do you want to add anything?
No, I just wanted to thank Ima for accepting this invitation and showing these results to the SIG community. And just add what I said at the beginning, that we have more seminars, so people who have come today are invited to continue coming to the other. And that's it. I have nothing else to add. Thank you, Ima.
Thank you. Very glad to share with you these results with you all. Okay, so we finished?
Yeah.
If anyone wants to ask me something, just please email me, or even Nadina, because she's one of the co-authors. Okay.